class today, geometry students, on Thursday the 12th. I hope you guys are doing well, and I do wish I could come by and see you guys. It's not like last year, like I've told you. I don't really have someone like Michael to watch the kids, so I do wish I could come by and see you guys, and hopefully I'll be able to do that. Somehow we'll work that out. But I hope you guys are doing well. Jay says, Zoo, Jake, and Martin, hope you guys are working hard. I hope you're ready for your test tomorrow, or I hope you will be ready for your test tomorrow. Please study. I know it's not fun. I know you probably really don't like the class, and you might even be starting or have been feeling for quite a while that you don't like me, and I understand that. But it is a geometry class, and we have to get the stuff covered. Okay, so please study tonight and be ready for your test tomorrow. First of all, there will be a test tomorrow, like I just said. That's announcement number 1. Announcement number 2, your review sheet is due tomorrow if you want the 5 bonus points. Now, if you don't want the 5 bonus points, you don't want to finish the review sheet, that's totally your decision, okay? I don't encourage that. I think you should do it, but that is your decision. Number 3, you owe me homework from Wednesday's class. That's yesterday, so would you please turn that in at this time? Please turn in your assignment from yesterday, and then basically that's it. Some of you, and again, Martin, if I'm wrong, then please ignore this and please forgive me, but I've heard that you and maybe some other students owe some technology permission slip forms. You need to get that taken care of because you guys are using the school technology every day for this class. I am going to be checking in the office with that probably at the beginning of next week to see who has theirs in. So please take care of that. It's just a rule. It's a guideline. Nothing wrong with that, and please get it taken care of. Okay, if you'll grab something to write with, I'm going to go pretty fast. I'm going to start going over right now the terms, definitions, postulates, theorems, etc. that you're going to, corollaries that you're going to have to know for the test. And I'm intentionally going too fast, so you have one of two choices. A, pause the video now and write them down as you go, or B, when you get home tonight, just write them down then and start studying, whatever you want to do. Let me get a drink of water here. Excuse me for a second. So again, I am going fast on purpose. That way, those that want to pause it can, and those that don't want to don't have to. This is what you're responsible for on your test tomorrow. This definition of a midpoint, definition of a segment bisector. None of these should be a surprise, okay? Definition of an angle bisector. A segment bisector divides a segment in the middle. An angle bisector divides an angle right in the middle. Complementary angles. Angles add up to 90, 2 angles. Supplementary, 2 angles add up to 180. Adjacent angles. Sorry, I was distracted there for a second. Adjacent angles share a common vertex and a common side, not interior points. Theorem. What is a theorem? It's a true statement that follows from other true statements. Theorem 2-1. If 2 angles are complementary to the same angle, then they are congruent. If two angles are supplementary to the same angle, then they are congruent. Postulate 7. By the way, can I say something? If you get these two turned around on a test, I couldn't care less. That's not a big deal to me. If you called theorem, if you said theorem 2-1 was if 2 angles are supplementary to the same angle, they're congruent, and for theorem 2-2 you said if 2 angles are complementary to the same angle, then they're congruent, why is that a big deal? I'm totally fine with that. Postulate 7, if 2 angles form a linear pair, then they are supplementary. Theorem 2-3, vertical angles are congruent. And then I want you to know the definition of law of detachment. Please know the definition for the law of detachment. If the hypothesis of a conditional statement occurs, then the conclusion will also occur. And that's it. So there we go. I think that's it. Let me get the eraser off. Sometimes I hide things at the bottom. I think that's it. Okay, that is it. So your review sheet is going to be page 95, 7 through 21. That's really lame. You've had some in the 30s, I believe. We did not get to the end of the chapter. We will finish chapter 2 next week and then move on to chapter 3. But I felt like we need to get this test in if at all possible. So we are looking at numbers 7 through 21 all. That's 15 problems, page 95. And you're welcome to pause the video now and work on the problems on your own, or you're welcome just to watch through the video and help yourself. But if you do finish early in class today, please don't cause problems. Find something else to do or study. Look at all these things you got to learn, guys. Study these, okay? That's something else you can do. So it's your decision now whether you want to watch the video and do the problems with me, or if you just want to work on the problems and then watch the video when you get stuck. It's your decision. And that's it. All right, the first problem, problem number 7. R is the midpoint. If your book's not open, please turn your book to page 95 and follow along. Number 7 says R is the midpoint of PQ. So this point right here is right in the middle. I should have labeled those. This is P, this is R, and this is Q. R is the midpoint, so it's right in the middle. And find PR and PQ. Well, if RQ is 5.5, and this is right in the middle, then we know PR also has to be 5.5. So that's pretty easy, 5.5. And then they want you to find the length of the entire segment, PQ, and that's pretty easy. This is 5.5, this is 5.5. Add those two together, and you will get 11. All right, moving on to number 8. Numbers 8, 9, and 10, actually you're finding the midpoint between 2 points. Now that midpoint formula off to the side, you're going to need to know that for the test. I'm not going to give that to you. And so this formula here will always allow you to find the midpoint between these 2 points that are plotted on a coordinate plane. So the formula says x plus x divided by 2. Well, this is x, this is y, this is x, this is y. So my 2 x's are 4 and 10. So 4 plus 10 divided by 2. My 2 y's are 1 and 9. So 1 plus 9 divided by 2. Of course, 4 plus 10 is 14 divided by 7 is 2. 1 plus 9 is 10 divided by 2 is 5. 7, 5. So 7, 5 is the midpoint of these 2 points here. Number 9, same thing. We have x plus x. This is my x. This is my y. This is my x. This is my y. So x plus x would be 4 plus 0 all over 2. Let me go back a page real quick. Okay. And then y plus y would be negative 4 plus 7 all over 2. And if you do that correctly, 4 plus 0 is 4 divided by 2 is 2. Negative 4 plus 7 is 3. 3 divided by 2 is 1.5 or 1.5 or 3 halves, whatever you would like to put. All right, number 10. This is your x, this is your y, this is your x, this is your y. And we're now going to use the midpoint formula. So negative 3 plus a negative 6 all over 2, and 1 plus a negative 5 all over 2. Now if you're good with your sign numbers, and I hope you are, then that's fine. If you need to use a calculator, that's fine also. Negative 3 plus negative 6 is negative 9, and negative 9 divided by 2 is negative 4.5 or negative 4.5, whatever you would like to put, or negative 9 over 2. All of those are fine. 1 plus negative 5 is negative 4. Negative 4 divided by 2 is negative 2. So that's the midpoint that falls between these 2 points. All right, let's take a look now at numbers 11, 12, and 13. 11, 12, and 13. If you look at the directions, it says BD bisects angle ABC in all 3 of these problems. Now what that means is it cuts it in half. So find the angle measure of what they ask. So in number 11, they want us to find the measure of angle ABC. So A, B, C. So they want us to find the whole angle. Now think about that. If we know this angle here with one dot is 25 degrees, then we know this angle here is also 25 degrees. So the whole angle has to be 25 plus 25. So the measure of angle ABC equals 50 degrees, 25 plus 25. Now, number 12. Here, they're telling us the whole angle is 130, the whole angle. And they want us to find the measure of angle ABD. So here's A, down to B, and then up to D. So they want us to find one of the small angles. Now think about that for a second, students. If the whole big angle all the way across is 130, don't think that this 130 is referring to this little angle right here. No, this 130 is referring to the whole angle. So if I take 130 and divide it by 2, I'm going to get 65. So what that tells me is this little angle here is 65 degrees, and this little angle here is 65 degrees. So I would say the measure of angle ABD, this angle right here, equals 65 degrees. All right, not too bad. All right, moving on to number 13. All right, now in number 13, what we notice is the whole angle is 90. It's a right angle. So if you take 90 and divide it by 2, you're going to get 45. So this angle right here is 45 degrees, and this angle here is 45 degrees. Now they want us to find the measure of angle DBC. So D down to B and then up to C. And you can see that angle is 45 degrees. So the measure of angle DBC equals 45 degrees. Okay? All right, moving on to number 14. Find the measure of a complement and supplement of a 79-degree angle. Now, let's go ahead and write 90, and let's go ahead and write 180. First of all, let's take 79 degrees, and let's subtract it from 90. And when we do that, we're going to get 11 degrees. So are you watching? 11 degrees is the complement for 79 degrees, because 79 plus 11 is 90. They add up to 90. So the complement of 79 degrees is 11. Now let's take 180 and subtract 79. We're going to get 101. So 101 degrees is the supplement of 79 degrees. 79 degrees and 101 degrees are supplementary because they add up to 180. So there's the two answers for number 14. Now, numbers 15, 16, 17, and 18, we're looking for the measures of one. Sorry, Philly yawn coming on. I apologize. We're looking for the measures of angles 1, 2, and 3. So, notice we have two lines intersecting, all right? Now, whenever you have two lines intersecting like that, you're going to have vertical angles and adjacent angles, okay, linear pairs. So, first of all, vertical angles are always congruent. So if this angle right here with one dot is 45, then this angle right across is a vertical angle. It's also 45 degrees, okay? So the measure of angle 2 equals 45 degrees. Now, remember when you have a straight line like this, then you have one line coming off of it. These two angles, one dot and two dots, the measure of angle 1 right here, they're called linear pairs. And linear pairs are always supplementary. Always, always, always. So if I've got 45 degrees right here, then I simply take 180 and subtract 45 degrees. I get 135 degrees. Angle 1 has to be 135 degrees. Okay? 135 degrees. So the measure of angle 1 equals 135 degrees. Now vertical angles, look guys, here's a straight line here, here's a straight line here, and these two angles are right across. Vertical angles are always congruent, so the measure of angle 3 equals 135. Now as far as I can tell, numbers 16, 17, and 18 are all identical to this, so I'm going to go a little faster, but they're all the same. Look at number 16. This is 116 degrees. I have two lines intersecting. If this is 116, you go straight across. The measure of angle 2 also has to be 116 degrees. They're vertical angles. Now, if you'll notice right here, I have a straight line with a ray or a line coming off of it. This angle here and this angle here are what we call linear pairs, and they're supplementary. So I'm going to take 180 and subtract 116, and I'm going to get 64 degrees. So angle 1 right here, this angle has to be 64 degrees. Now look, 64 degrees and angle 3, this angle here, they're vertical angles. They're across from each other, so angle 3 is 64 degrees. So the measure of angle 1 equals 64. The measure of angle 3 equals 64 degrees. Moving on to number 17, same thing. We have two lines that are intersecting. We have a line here and a line here. So we have vertical angles and we have linear pairs or adjacent angles. So here's 81 degrees. We go straight across to angle 2. The measure of angle 2 equals 81 degrees. Now hopefully you're starting to see this. This is the third problem we've done. This angle right here and this angle here, they're linear pairs. They're on a straight line with a line coming off of it. So we know they're supplementary. They add up to 180. So I'm going to take 180 and subtract 81 degrees. And I should get 99 degrees. So the measure of angle 1, sorry about the delay there, I'm getting a little old these days. Measure of angle 1 is 99 degrees. So if this is 99 degrees, then we know 3 is also 99 degrees. Vertical angles are congruent. Okay? And then last but not least, number 18. Well, we've got two lines again that are intersecting, and whenever two lines intersect, the vertical angles are congruent. And so, if this angle here is 148, then the measure of angle 2 is 148. So the measure of angle 2, 148 degrees. Now, then notice next, we have a straight line right here with a ray coming off of it. So this angle and this angle are what we call a linear pair. They're supplementary. So 180 minus 148 would be 32 degrees. So the measure of angle 1 equals 32 degrees. Now, if 1, this angle here equals 32 degrees, vertical angles, the measure of angle 3 also has to equal 32 degrees. Okay? Almost done, guys. Cruising right along. Hope you're getting this. All right, number 19. For 19 and 20, they want you to write the statement in an if-then statement, underline the hypothesis, and circle the conclusion. So they have given you this phrase right here. Every computer in the store is on sale. Now, they want you to write that as a conditional or an if-then statement. So I would say, well, here it is. I've got it right here for you. And there's more than one way to write this. There's a little bit of leniency, but if a computer is in the store, then it is on sale. Now, you could also say, if computers in the store, then it's on sale. That's fine. I just try to make it a little smoother like I've told you guys before. Now we're going to underline the hypothesis, if a computer's in the store, and we're going to circle the conclusion, then it is on sale. All right, number 20. I'll go to the mall if you come with me. Well, this is the if part. Look, you can't say, if I go to the mall, then you'll come with me. No, that's not right. If you come with me, then I'll go to the mall. So the if part is actually written at the end this time. So the right way to write this is, if you'll come with me, then I'll go to the mall. That is the correct way to write that. This is the hypothesis, and this is the conclusion. Now 21 is a little different. The directions for 21 states, use the law of syllogism to write the if-then statement that follows from the pairs of conditional statements up here. So let's see if we can figure this out. If Mike goes to the concert, then John will go to the concert. If John will go to the concert, then Janine will go to the concert. So if Mike goes, we know John will go, and if John goes, Janine will go. So we could say then, we can take the if part from this conditional and the then part from this conditional and put them together, and we can say, if Mike goes to the concert, then Janine will go to the concert. Students, I care about you guys. I hope that you're working hard and doing your work. Please be responsible. Please work hard and do what you need to do to be successful in this class. Study for your test and have your review sheet done by tomorrow if you choose to do that.